So I mentioned it already, we have biological effects. And when we look to the newspaper, there are tons of biological effects reported and mixed up, and maybe you don't know exactly what is what. So we have, for example, the risk of cancer, we have heating, we have reflexes, we have influence on cell growth, and so on. So I would like to sort this a little bit out, but pay attention, I'm not a doctor in medicine, so this is just my knowledge here. So we have so-called long-term effects. For example, risk of cancer. This is for sure a long-term effect because cancer does not come overnight. Influence on cell growth and so on. This is always something which takes a long time. On the other side, heating effects or reflexes is something which happens immediately, and in the moment when you switch off the source, also this effect disappears. Okay, cancer will maybe stay. So long-term effects, short-term effects. Short-term effects, these are effects we know. We know exactly because the heating we can measure and we can try it out. We can put a frozen chicken into a microwave oven and we can measure the heating inside of the chicken. Okay, no problem. The risk of cancer, the long-term effects, these are effects where we don't have a proven link, luckily up to now, and I hope they will never find a link there. Okay, so the short-term effects are also the base for legislation most of the time, because here we know exactly when we get a heating and then we have to limit our radiation. The long-term effects, as we don't have a proven link, how do we want to set the limit values? But some countries have a solution for that. And when we talk about biological effects, we also can distinguish between the biological effects in low frequency and high frequency. In general, both we have two kinds of biological effects, stimulation effects, so that for example, the hair on your skin is rising or your muscle gets disoriented. These are stimulation effects by currents through your body. On the other side, we can also have the thermal effect, means you are heated. Uh, in general, we have both effects at every frequency, but in the low frequency, the stimulation effect is a major dangerous effect. The thermal effect is not so important. On the other side, in high frequency, the thermal effect is a more dangerous effect because the stimulation there is not as high. Okay, so low frequency stimulation, RF, thermal effect. And remember, we also have two kinds of fields. We have electric field and we have magnetic field. So if we have a homogeneous field and we are standing inside of it, for the magnetic field, your body has no impact. The magnetic field goes through nearly everything, even through metal. You nearly can't shield a magnetic field. It goes through walls, through buildings, as I mentioned, through most of the metals. There are some metals which can also shield magnetic fields, but in general, for our measurement procedure, this means the measurement of magnetic field is quite easy because you can have your test equipment even inside of your pocket. It doesn't harm the magnetic field. On the other side, the electric field is changed by any kind of conductive material, and your body is a piece of conductive material. And when you are present in the electric field, you are changing the behavior of the field. It's not longer homogeneous. Okay, so this is something you have to take into care when you measure electric field. I mentioned it in the high frequency, you mostly use electric field probes because they have a higher bandwidth. On the other side, keep your probe away from the body because your body is changing the field. Okay. When we look now through into a homogeneous electric field, we can see here by an experiment or by simulation what an electric field, a homogeneous electric field of 10 kilovolts per meter is doing with your body. You can see at the top of your body you have 180 kilovolts per meter, so there you have a much higher field strength, and it's inducing a current into your body, and you can measure here how much current is flowing, okay, by an electric field. Okay, now that's the question, when does it influence my body? Because remember, also your brain is sending little currents through the nerves into your hand and is telling the hand, open the hand. So if there is now a parallel current flowing through your body, maybe there is a disorientation of your muscles by the current which is produced by the electric field. You can see here with 10 kilovolts per meter, we have around about, yeah, let's say 1, 2, 3, 4 milliamperes per square meter surface. So when we now go and have a look, 10 kilovolts per meter, so below 1 milliampere, we go back below 1 milliampere. Here in the body we have 1.6 milliampere. Below 1 milliampere per meter squared, there are no known effects. Between 1 and 10, we can see some weak biological effects. Up to 100, effects can be clearly demonstrated. Up to 1 ampere, we already get our first problems, and above 1 ampere flowing through your body, then we have really strong effects. But even in a field strength of 10 kilovolts per meter, we are far away from 1 ampere per meter. And 10 kilovolts per meter is already a lot. When you measure, for example, in your living room, you will see there is a field strength of 2 volts, 3 volts, maybe 5 volts per meter, but not 10 kilovolts, 10,000 volts per meter. So inside of a living room, you are far away. Such kind of field strengths you will only have directly under high voltage lines. Okay? And then we will see some weak biological effects. On the other hand, so this was the effects on low frequency. On high frequency, I told you we have the heating effect. And here we see, for example, a finger which was on an RF connector where a strong amplifier was sending out an instrument and a strong signal. And you can see here a small burn. The problem with those kinds of burn, normally you would say, oh, what a little burn will not give any result to my body. But be aware that as lower the frequency, as deeper the burn goes. And especially to mid-frequency and 100 megahertz, you will have a heating inside of your body and not on the surface. With very high frequency, you have a surface burn, as you have it by the visible light of the sun, for example, then the surface is burning. But with lower frequency, you have an inside burning, okay? And your receptors, your sensors for feeling heat are on the skin, because those fields are not known to our bodies. These are not natural fields. So when you feel the heat on the surface of your skin, maybe your inner part of the finger is already overheated, okay? And this takes a long time to heal, okay? So this doesn't look harmful, but maybe inside the burn is maybe much higher. So this was 3 times of the perception level. What you can really do with RF energy, I can show you by this little picture. This was 20 kilowatts at 7 gigahertz. This was burning a hole into a piece of wood within 7 minutes. So RF energy can be really dangerous in terms of burns, but you don't have any application at home which can generate 20 kilowatts, okay? And not at 7 gigahertz. No way. You don't have such kind of application at home. In industry, and you can have such kind of things. For example, when you are heating metal and melting metal, you have very strong magnetic fields, for example. Okay, these are induced current because they are low frequencies. But for example, for coating metal and so on, you can have very, very strong electric and magnetic field. And I myself was during my military time, I was in the Navy, and I was in charge of the radar and I didn't know anything about electromagnetic fields. I even don't have any testing equipment for electric fields. So the first help is knowledge about electromagnetic fields. I didn't know anything about it, and if I wanted to test if the radar is working, I opened the waveguide and hold the hand in front of it. If my hand was getting warm, I was saying, okay, yes, the radar is operating. I did not know at that time that my hand was cooked. Luckily, the tube, the waveguide, was high enough inside of our boats that I could not look inside, because this brings us, well, you shouldn't do it like him or like me. This brings us to a part, what kind of RF energy do I need for heating? And if we have, for example, a bad neck, we can also use RF energy for a therapy. Remember, we were also talking about X-ray, and that X-rays are not good for your health. Okay, nobody will go into an atomic plant and go into the dangerous area there. But if your arm is broken, you will tell the doctor, yes, I accept X-rays so that you can repair my arm again. The same happens with, if you have a bad neck, for example, due to a cold wind, then you go to the doctor and you ask him to put some big electrodes onto the body and heat your body from inside. This is done by 27 or 433 megahertz. Okay, so if your body is in rest, your body is producing 1 watts per kilogram to keep the body warm at 37 degrees. Okay, with light activity, you are beginning to sweat, and then you are producing 3 to 5 watts per kilogram body weight. Okay, and your body is reacting to keep the temperature stable, and you are beginning to sweat. Okay, in an RF therapy like here, you are exposed to 10 to 50 watts per kilogram. Now you can say, well, then I must sweat here a lot. No, this is not, because your body also has a cooling system inside, which is called blood. So the blood flow is transporting the heat away and is distributing the heat over the entire body. But the maximum is still here, good for your health. So if you want to heat your body from 37 to 38 degrees, for example, by 1 degree, you need for the entire body an exposure to 4 watts per kilogram body weight. Okay? If you are exposed with the entire body to 4 watts per kilogram, then your body temperature will rise by 1 degree within 6 minutes. 6 minutes, this is a factor we will see later on in averaging. There, the 6 minutes are coming from. Okay, after 6 minutes, your temperature regulation has started operation, and it keeps your body stable, not longer at 37, but then at 38 degrees. Okay, it's not rising infinitely, luckily. IGNIB is saying, or most of the standards saying, okay, for workers, we want to put a safety factor of 10 onto it. So an exposure up to 0.4 watts per kilogram absorption is allowed for a worker. And for general public, again, a safety factor of 5 onto it. So 0.08 watts per kilogram is allowed for general public. So you can also say 0.1 degree body heating is allowed for a worker, and an additional factor 5, so 0.02 degree heating is allowed by electromagnetic fields. Okay, so this is acceptable. This is not dangerous by definition of many standards. I told you I put my hand in front of the open waveguide, and I told you also, luckily, I never looked inside. When I heard about the first time about the effects of electromagnetic fields and the heating, my first idea was I have to protect my brain and my heart. But this is not correct, because especially the heart has a lot of blood flow, and the brain also a lot of blood flow through it. So they are not our major problems in terms of heating, but the lenses of the eyes, for example, they have no blood flow through it. So that means your lenses of the eyes will be cooked immediately when you look into a waveguide of a radar, for example. Okay, so whenever you see a tube of a waveguide which is connected to any kind of transmitter or a big coaxial cable where you don't know what kind of signal is on it, never touch it, never look inside or whatever. Okay. Lenses of the eye, kneecaps are natural things, but we also have a lot of not natural things, for example, teeth fillings. And I once talked to a rigger in the UK, and he was standing in front of, in an elevator in front of an FM tower, which was operated, and his teeth filling were melting. This is not funny. I had a lot of problem to understand it because it was hard for him to speak. Okay, so any kind of metal, the teeth filling, your marriage ring around your fingers, and so on, all these things are getting heated. Or if you have, for example, metallic implantates, very, very dangerous because they get heated first. Okay. So how much they are heated depends a little bit on the frequency, because you know also from antennas, you have antennas with different lengths, with different height, depending on the frequency on which they should operate. This is like your body. Also, your body has a so-called resonance range, and so not every frequency is heating your body in the same way. We have a range between around about 10 megahertz up to some 100 megahertz, 400, 500 megahertz, where we are in the resonance range and we absorb the RF energy best. So here the limit values have to be the lowest one. That's why you always see in on most limit values such a curve, which is having here between 10 or 27 megahertz up to 400 megahertz, the lowest limit value, because here your body absorbs best. Okay, to higher frequencies, a little bit more is allowed. To lower frequency, also the limit values are rising normally.